For thousands of years, man looked up into the night sky and pondered the mysteries so far beyond his solving. Now, abruptly, he has found ways to bridge the gap between this Earth and other worlds. For man, a new era has been born, the age of space. What will life be like in this new age? Century 21 tries to answer that question by constructing a vivid, realistic projection of man's world tomorrow in 5 main areas of his environment. First, the world of Century 21. How and where man will live, work, and play in the next century. And the world of commerce and industry, the machines, materials, methods, and products of tomorrow. Next, the world of visual art. The line and shape and color of man's creative activities in a world of vastly increased leisure time. Then there's the world of science, a fascinating panorama of tools and techniques that man will use to probe deeper into space and into the mysteries of life itself. And finally, the world of entertainment. Music, dance, drama, sports, and of course, a futuristic gateway designed for sheer fun in any century. These are the 5 worlds of the Century 21 exposition.
Under Exposition President Joe Gandy, Century 21 audaciously bid for approval in Paris by the Bureau of International Expositions. To get it would mean that no one of the 30 European member nations could officially exhibit anywhere except at Century 21 for the next 10 years. Visitors moving from one world of Century 21 to another will walk the boulevards of the world, a pattern of streets and avenues lined with colorful shops, bazaars, bars, and restaurants. Century 21 did get it, thanks in a big way to being able to produce no strike pledges for the exposition period by Seattle area labor unions. Just east of this work and extending north toward Mercer Street is the central mall of the exhibition grounds. Along this mall, to be lined with trees, one feature will be an international water sculpture display like nothing ever seen before. Across the way, the Armory is being transformed into a food circus pavilion to feed and entertain the hungry multitudes. The Exposition Central Boulevard extends from Mercer Street along this side of the Armory and on south to a scenic knoll and the 5-unit U.S. Science Pavilion, another of the 5 worlds of Century 21, the world of science. Near here will be erected those buildings that will showcase the tomorrow look of U.S. industry. Moving then back to the north again, we come to the spot where workmen are now busy driving pilings. This is construction for footings for what will be an exhibition hall, and to the west of that, a new playhouse. And farther east, the old ice arena is also due for modernization. And the parking lot on the corner of 5th and Mercer becomes part of the Gateway 21 amusement strip. Then moving south again, we pass the stadium, which will be integrated into the exposition grounds and used for Century 21 events. And from there, on to the monorail terminal and to the Space Needle with its tower restaurant.
Before he is destined to take a giant stride into history, Colonel John H. Glenn, Jr. squeezes into his spacesuit. His smiling face belies the 10 postponements of his flight that have kept him grounded. This morning, the weather over Cape Canaveral and in the pickup areas is better, and there's an air of optimism as the Colonel walks to the gantry elevator. Carrying his now familiar portable air conditioner, Glenn prepares to go to the 11th deck as clocks point to 6 a.m. Eastern Standard Time. The skies are beginning to lighten, and a cool north wind rustles across the Cape. The Colonel's date with destiny comes 10 months after the Russians claimed an orbital flight by Yuri Gagarin, and less than a year after Alan Shepard blazed a suborbital trail for the U.S. This is the climax of 3 years of training. This is the moment when the eyes of the world turn to Cape Canaveral. The Russian orbits were in a thick fog of secrecy. The United States stands or falls in the white-hot glare of worldwide publicity. In the capsule atop the Atlas missile, the colonel will be strapped to a contoured couch. Once in flight, the Mercury will be tilted so that the astronaut will ride backwards. The seconds tick off as his rendezvous with space approaches. The hatch cover causes a slight delay when a defective bolt is discovered. Then, millions are moved to silent prayer. Everything is go. The takeoff of the Atlas, blasted off by 360,000 pounds of thrust, carries the Mercury gracefully skyward. The Friendship 7, climbing rapidly out of the Earth's atmosphere, exerts a pressure of 6 times the force of gravity on the astronaut. Loud and clear, he reports back to Mercury Control, reading off his instruments, commenting on his reactions, all as coolly and calmly as if he was commuting on the 827. Glenn is able to control the yaw and pitch of the vehicle himself. Now comes the moment when the Mercury is turned so that Glenn will be seated facing backwards. He checks with ground control.
Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous. Roger, turnaround has started. Capsule turning around, and I could see the booster during turnaround just a couple of 100 yards behind me. It was beautiful. Roger, 7. You have a go, at least 7 orbits. Roger, understand go for at least 7 orbits.
Actual pictures of Glenn in the capsule will give scientists the opportunity to study his reactions as he passes over the Canary Islands, Africa, the Indian Ocean, Australia, back across the Pacific and over the United States. He speeds at 17,500 miles an hour, reaching a high point of 160 miles and a low altitude of 99 miles. Each of the 3 orbits takes about 90 minutes. 3 times the colonel sees the sun rise within a period of 4 hours and 56 minutes. 3 times around the globe for a trip of 81,000 miles before he re-enters the Earth's atmosphere, a shield protecting the astronaut from the intense heat. The carrier Randolph is the command ship in the pickup area, but Glenn, instructed not to jettison his retrol rockets, lands short of the carrier. Ground instruments indicated his heat shield was loose, and he was instructed to hold onto his rocket bank to help hold the shield in place. Right at hand, however, is the destroyer Noah, and she speeds to the capsule to take the vehicle and pilot aboard. Despite a few shaky moments among ground control personnel, Glenn is down, hale and hearty. With support cables attached, a pincer-like crane will lift the Friendship 7 aboard. End of a saga. The now famous Friendship 7 is safely lashed to the deck of the destroyer, and the crew prepares to help Glenn from the capsule. First, they attempt to help the colonel from his complex prison through the upper exit in the mouth. They encounter difficulties, and so it is decided to blow off the escape hatch cover. First glimpse of the conquering hero, Colonel John H. Glenn. He left his footprints among the stars. He has a grin as wide as the path he blazed as he rests briefly before being flown to the carrier Randolph by helicopter. He is lifted aboard in a maneuver that looks more dangerous than the flight itself. The helicopter takes him to the Randolph for a debriefing and examinations by medical men. The copter no sooner touches down on deck than Glenn gets a preview of the congratulations that are still to come. On every hand there is jubilation. On every side, smiles and cheers. He signs over his precious log and instruments to the National Space Administration. From here he goes to Grand Turk Island for further rest before the deluge. A deluge of honors a proud country waits to bestow on a brave man.
You're watching Sleepcore. Pleasant dreams.
From a ground station nestled in the mountains at Andover, Maine, a signal is sent to a speeding satellite, an historic feat that could reshape man's future. That satellite, of course, is the Telstar, 170 pounds of complex electronic equipment that receives signals beamed from Earth, magnifies them 10 billion times, and rebroadcasts them back to Earth. Pictures, telephone calls, telegraph messages, and computer data all can be handled by the orbiting device. The Telstar receives its power from batteries that are recharged by the sapphire-coated solar cells, which in turn are activated by rays from the sun as it hurtles through space at a low point of 600 miles to a high of 3,500 miles. The Telstar is sent aloft from Cape Canaveral atop a Thor Delta rocket in a joint industry government effort. The Space Administration team handles the launching for AT&T, and it's a $50 million phone call for the telephone company. Future plans call for the orbiting of 20 to 25 satellites like the Telstar. Thus, when one passes out of range of ground stations, another will be coming into position. Presently, along with the ground station in Maine, there is a receiver and transmitter in Great Britain at Cornwall, and in France on the coast of Brittany. Even as Telstar is launched, the French rush to complete their installation to receive a signal that night. Now the rocket climbs far into the atmosphere, and the Telstar is about to separate and orbit the Earth each 2.5 hours. Starting with the 6th orbit and through the 9th, the Telstar is in range of both the U.S. and European stations, and pictures are received clearly in France, with somewhat lesser success in Britain on this first test. The signals are beamed from this 18-story dome that houses the super-sensitive horn weighing nearly 400 tons, an antenna so delicately tuned that it picks up a mere whisper of a signal from the satellite and amplifies it again billions of times for rebroadcast over cables or the air. Now comes the historic moment, a moment compared in significance with the first message sent over the telegraph. This is the first picture transmitted to outer space and received back again on Earth. Scenes of the dome at Andover are flashed across the sea, and man marks another milestone in this age of scientific miracles. So proudly it waves. What does the future hold? Well, scientists visualize a belt of Telstars encircling the globe in such a manner that transmission will be continuous around the world. Both sides of the Earth can be in immediate photographic contact, communication that could bring better understanding among men.
The problem is really quite simple. Find the best path to get from point A to point B. But now let's make some assumptions. Let's say that point A is on Earth. The Earth is rotating. It's also wobbling on its axis, which means that point A is actually moving like this as it travels through space in its orbit around the sun. Now let's assume that point B is on the moon. The moon is also rotating. The moon is also wobbling on its axis, which means that point B is describing a motion like this as it travels through space in its orbit around the sun. Besides this, the moon is moving around the Earth. So point A and point B do not stay the same distance apart. Also, the Earth and the Moon each have a different strength gravity field. This means that the direction and intensity of gravitational pull will change constantly along our selected path. Because of the movements, the sun does not always illuminate points A and B. We would like to leave A when it's lit and arrive at B when it's lit. The problem remains the same. Find the best path from point A to point B. But of course, this is a great oversimplification.
A space probe, unlike an ordinary Earth satellite, seeks out knowledge in regions far away from the Earth. As shown here in this historic film of the first probe, American Pioneer 1 was launched in 1958. First, it was placed in orbit about the Earth. Then another rocket was fired. The speed of the payload was to be boosted to 25,000 miles per hour, the speed necessary for an object to become free of the gravity of the Earth. No longer an Earth satellite, the space probe would then be free to coast to its far-off destination and radio back its findings by telemetry, the technique of transmitting or reading instrument recordings from a distance. Batteries are used to power instruments which detect and analyze various phenomena, and to power radios whose antennas send the findings back to Earth. This is how a space probe operates to bring us new knowledge. Pioneer 1, however, failed to escape the Earth's gravity and fell back, burning as it re-entered the Earth's atmosphere. In 1959, Russian Lunik 1 and then American Pioneer 4 were sent into space and beyond the moon. Lunik 2 revealed that the moon had no magnetic field. The discovery was made just before the probe hit the lunar surface. Lunik 3 was so engineered that it curved behind the moon and took photographs of the side that had always remained hidden from the Earth. Pioneer 5 was the first interplanetary probe. It was aimed at Venus and launched in the year 1960. In 1961, a Venus probe was launched by Russia. Both probes failed to get information about Venus. Both went into orbit about the Sun. But a new era had begun. Larger, more powerful rockets allowed larger, more sophisticated payloads. So man took his first step. First the Russians, then Americans successfully orbited the Earth in the early 1960s. The next step will involve sending crews into space. The problems solved by such a project will undoubtedly lead to landing the first men on the moon. The second generation of moon probes, such as this Ranger, have helped to prepare for such a landing by collecting and relaying back information, by televising back to Earth details of the moon's surface. The same telemetry methods will be used for the more sophisticated moon probes, such as surveyors, designed to make an even more detailed study of the moon. Equipped with an elaborate system of solar cells, the surveyor will turn sunlight into electricity to power its instruments and radio. Because this side of the moon always faces the Earth appears suspended in the moon's sky and can always be seen because there is no atmosphere, clouds, or haze on the moon. Delicate instruments whose measurements can be affected by even the presence of the spacecraft are held away from the craft by long, mechanically operated arms. Mirrors reflect into the lenses of the television cameras a close look at the harsh, irregular surface which, except for meteorite impacts, is believed to have remained the same for millions of years. Meanwhile, other probes are being planned. Some will study the moon as they orbit around it. Some will explore the solar system, shown here by concentric circles representing the paths of some of the planets as they orbit about the sun. Nearest the sun is Mercury. Venus is next, then the Earth, then Mars. Because Venus and Mars come closer to the Earth than the other planets, the first probes have been in their direction. There are times when Venus is only 25 million miles away. However, at other times, it can be as much as 162 million miles away. Mars, our next nearest neighbor, is sometimes as close as 35 million miles away, but when the Earth and Mars are on opposite sides of the sun, the distance is sometimes as great as 248 million miles. As a result of these variations in distance, space probes are launched only during those periods when the target planet is in a favorable position. Between 1965 and 1975, only certain years are favorable for probing Venus and certain years for Mars. Specially designed for interplanetary travel, the Mariner is capable of traveling great distances and sending back information gathered along the way. Shortly after launching, solar paddles unfold like butterflies' wings. Sensors cause the paddles to face the sun. Solar cells are used to convert sunlight into electric power needed for telemetry. Through the nearly perfect vacuum of outer space, telemetry has already successfully functioned over a distance of 54 million miles. Radiation counters aboard the probes have revealed that the sun constantly radiates streams of electrically charged particles called the solar wind, as symbolized here. During a solar flare-up, the radiation increases. How does this affect the Earth? Well, the Earth, like a bar magnet, is surrounded by lines of magnetic force, shaped something like this. Space probes have proved that the Earth's magnetic field controls the paths of the charged particles from the sun, trapping and forcing them to circulate within the field. Some escape to form the Earth's aurora borealis. Some escape back into space. But the dense accumulation that remains is called the magnetosphere and is symbolized here by this model. The magnetosphere is now known to be very dangerous to space travelers. Space probes have also discovered new facts about the planet Venus. A surface temperature of 800 degrees Fahrenheit, which would prevent life such as exists on Earth. Venus, like the moon, rotates very slowly. Probes have found no magnetic field. But because there is a strong magnetic field around the fast-spinning Earth, many scientists now conclude that a magnetic field is caused when a celestial body rotates rapidly. Future probes will undoubtedly provide the answer. Space probes are mechanical scouts reconnoitering man's new frontier. Already they have warned him of the magnetosphere and its deadly radiation, of the searing death that lurks beneath the clouds of Venus.
13, 12.
As the Earthling learns to become a spaceman, he must ask himself many questions. Can I survive out there? What will I learn? What contribution can I make with this new knowledge?